Hello, hello. Today is June 5th, 2024. This is working group serving. Welcome, everybody. Okay, today on agenda, we have a few items. And first item from Clayton, and I don't see Clayton yet joined. So maybe we can skip and...
I can
Okay.
maybe take it, Sergey.
Okay.
And Clayton can add stuff if he drops in later. So Clayton shared a doc with some extra details around auto-scaling LLM, and invite everyone to take a look. It kind of breaks down various like user intent with regards to how you would want to auto-scale these things. And what we're really hoping is this could feed further discussions within the auto-scaling workstream about, how, if I was a user, how would I apply these using the Kubernetes primitive? So yeah, so hopefully we can get that scheduled soon and then continue the discussion there with more of a focus on the workload.
You also want to report back on a Friday meeting?
Yeah, why don't I do that right now? So we discussed a little bit more in the auto-scaling workstream last week. The discussion was definitely a lot more on the infra side of the world. So in terms of like bringing up warm nodes with respect to cluster autoscaler and Carpenter, I think the next direction we'd like to move into is more on the workload side. So, having warm nodes doesn't fully mitigate a slowly starting workload. So can we think about ways to, also mitigate that side of it? So I think, with Clayton's doc and so on, we'll hopefully be able to spur some ideas and some discussion there.
Yeah, I wasn't able to attend, but I heard some discussion about Carpenter versus cluster autoscaler, like on the recording. Is there any follow-up on that? Do we think we can agree on some common models or common constructs that will be useful for both?
Yeah, I think that's the idea. The discussions are still early there, but I know that there are folks who are very interested in doing this. So yeah, we should continue making sure we make progress on that. So in terms of like concrete like agreements, that's not yet the case, but I think it's moving in that direction.
Okay. If you're interested in a recording, there is a recording in one of the links. Yeah, I think this is a link. It's in the same notes document. Okay. Next, I know Yuan cannot join, but Kai can update on orchestration workstream.
Yeah. I think Terry said that he cannot attend this meeting today. So I talk about a bit about the workstream, architecture workstream. I think last week I think I invited the reserve team, and I give some presentation about the reserve on Kubernetes, and here's a slide. And I think last week is just 1 hour, so a lot of questions that we don't have time to discuss it. So I think Terry will schedule another follow-up call to discuss that. Yeah, and if you are interested in that, you can see a slide that also attached in our meeting note. Yeah, cool. Thanks.
Is there any questions for orchestration workstream? Yeah, I wonder what will be next steps. Maybe we can wait for Terry to define some next steps, like what we can discuss next. Okay, Chong.
Yeah, so I think last week we we discussed about model rollouts and how to deploy model with Kubernetes, and I promised to write a doc and summarizing what are some of the patterns people use today. So I just share this doc here. So feel free to comment and edit. If I missed anything, please feel free to add. I was wondering for this group, there are a lot of ways of downloading the model weights to a workload. There doesn't seem to be a best practice, or so I wonder people's opinion on whether at this group we should come up with some guidance on how do you download model. I think the Kelly's cap on mounting containers as sort of like a files or data also interesting. That could be a way, like a more Kubernetes way to distribute model weights. So I was wondering if anyone's on the call on the cap, if this is distributing model weights is one of the use cases you have in mind of proposing that cap.
I didn't get the question. Can you repeat the question?
Yeah, my question was last week. I think Kelly had a cap on mounting containers as volumes. I mean that could be a way of building model weights into containers and distribute that to your workloads. I wonder if that's one of the major use case of this cap, or there are other use cases, or other thoughts on this.
Yeah. Hey, I worked on Sally a little bit on this. That is pretty much the primary use case that we're looking at, is attaching models to containers without including them inside of the image.
Cool. It sounds to me like using containers is a good way, because we're on Kubernetes and we talk containers language, and a lot of people also have the weights coming from maybe some remote bucket like GCS or S3, and using something like a GCS fuse to directly mount that seems to be very convenient. That's another way that you can distribute weights.
Totally. Yeah, I think the use case that we're looking at is not only the storage of it, but also like the sort of distribution of it. Like if we're looking at an cluster auto-scaling case, like how do you actually get the model to that cluster without directly attaching the S3 or other. So like which is the idea of distributing it with OCI artifacts.
Can you elaborate a little bit more on the auto-scaling case? Like, are you thinking about like leveraging the cache to speed up the auto-scaling? Or?
Well, so my personal idea, I'm sort of working with this. I'm not like directly there, so I don't have the entire full context. So part of my line of thinking is if we're able to leverage OCI, if we're like using the CRI implementation to actually be moving the registries around, then we can leverage things like lazy pulling or peer-to-peer image moving that would allow us to sort of like inside of a cluster distribute it easier, or and then the auto-scaling piece, just more thinking about like when we're bootstrapping a cluster or a node, like how can we most efficiently move the model somewhere, and being able to distribute with OCI artifacts just feels like a good fit.
Got it. Thanks.
Yeah, I think for me, OCI is just very easy way to version models, like version and better consistency, and like even like maybe check for consistency if needed. So GCS is I mean ultimately in Google, GCS is a backend for images anyway. So you download from the same place. Ultimately, it's just metadata that associated with this OCI image that is important.
plus all of the tooling and stuff that is built around OCI images now.
Chung, do you want to give some overview of your document, or just we want people to review first?
Yeah, I think I'll want to put it on review first. I think thanks for some of the comments. I'll try to capture some pros and cons in the doc.
Okay, Abdullah, you have a hand. You had it before as well.
Yeah, because like I lowered my hand because I had a different topic from the model rollout. Oh, well, actually, it's related. I'm trying to sketch out like quote unquote workload API or ML or like serving workload API. I should have something out like probably next week, like for general, like, or maybe in 2 weeks, general review. But I just want to gauge interest in this concept in general. Is the community interested in, like, or has anybody like thought about something along the lines of like a serving deployment to basically make it easier to express, like, what a serving workload needs to deploy, and then simplify the actual deployment.
Can you maybe give a little bit more details, like how is it, for instance, related to Kaito, and how is it related to LWS? Like, is it, or it's like earlier stage? Was it?
That's a good question. So LWS is focused on a specific, use case, which is multi-host. But at the end of the day, it still like has the pod spec and like, it's just like a deployment API, but specific for multi-host. But this one, the thinking is to have something where the workload owner, when they create the workload, doesn't really need to deal with the pod spec, all these details, right? They just say, okay, I want to deploy a model, and I want to use this accelerator, and then some magic happens in the background. Now, the thing is, like, how that magic actually manifests itself is, to me, the main challenging piece. Like, I know Kaito, for example, have their like presets that are baked into the code of the operator. KCF has like something specific to various frameworks like PyTorch and sklearn, etc. But what I'm thinking is something more specific to LLMs, because it seems like a more specific use case where we can come up with an API that is simpler and yet extensible. The goal here is to find a way to deliver presets or configurations in a way where you can, like, the platform engineer could basically, it doesn't, like, it's not locked out of how to change those presets. Like, for example, with Kaito, it's hard to change those presets. If you want to change something, you have to go all into the pod spec, right? Like, you have to change, you're basically getting exposed to all that complexity. I think same thing with KCF, like, you have to go with the raw deployment route. Anyways, like, that's just like a few thoughts here I have. I was just like teasing out interest here. But I'll have something available for the public probably next week to look at.
Yeah, Jackson, have a question?
Yes, Abdullah, I'm curious, like, so this will be some like API spec or some solutions. I do see the challenge here is defining like in Kubernetes area, defining an API stack there normally come with the controller code, right? And we need to make sure, like, all other like solutions like LWS or Kaito or other like orchestration solutions to leverage this lower level API. And I think that's kind of the hard part to define some like standardizations, especially at the lower level. So what's yourself now? Do you think that what's the what it looks like?
I'm thinking of like if you think about the personas that manage and deal with this workload, we're thinking about like 3 personas. One is the workload owner, someone who just wants to deploy, you know, like a serving workload. And I think, for example, with Kaito, that's most of the focus is on that persona. The idea is we want to simplify that user journey. I want to deploy Llama. I have some H100 capacity. I want to deploy it there, right? How to create actual deployment, how to create HPA, etc., is kind of like, you know, not managed, but at least it's like an artifact of you, like the workload owner expressing that intent. And then the second persona in my mind is like the MLOps, or the platform engineer, let's call it. This persona has a lot, like more experience with Kubernetes in general. They want to know the details of like the pod specs and the deployments, etc., because they are probably managing other workloads in the cluster as well. But I want them to be able to express those presets or canned configurations to the workload owner, like have a mechanism by which they are able to express those pre-canned configurations. So those pre-canned configurations, as you mentioned, like sometimes, like if you bake them into the code, it would make it really hard for that persona to change them, extend them, etc. So I'm thinking of like, okay, how do we come up with APIs that allows the workload owner to express that intent, but also the platform or MLOps engineer to create instances, I'm calling them blueprints or templates, of those preset configurations that the workload owner references when they want to stamp out a new serving workload. And then the third persona in my mind is like the cloud providers. They could provide those like presets and configurations sometimes that are optimized for their platform, right? Like, for example, in Google's case, we have TPUs. We can like, you know, create a template or a configuration, preset configuration for you to optimally run multi-host on TPUs. But then I don't want the platform engineer to be completely locked out from tweaking some aspects of it. And in my mind, like that blueprint API would provide this, like, you know, mechanism by which the cloud platform can provide those like blueprints. The platform engineer who's actually managing the Kubernetes cluster can clone them, modify them, like, you know, customize them a little bit for their specific use case. And then the workload owner would just basically reference one of those blueprints when they actually want to create, you know, an instance of the serving workload. Now, the challenge is, of course, in the the devil is in the details. But at least that's the conceptual picture that I have, and I'm trying to formalize a little bit. Does that answer the question?
Yes, definitely. Yeah, I think in like in our like use case, especially for those simple cases, we do have the similar problem. But underneath, we still for those cases we use like kind of the deployment, but have some abstraction. So people won't directly operate deployments. Instead, they have some abstraction to use. Yeah, I'll check with you offline on this. Let's see whether there's better abstractions.
Yeah, definitely. Like I want to get community's input and see if this is something we can evolve to get that at least at the API level.
Sure, Abdullah, this is Fei. If you have some draft data, I'd like to join the discussion.
Definitely, yeah. Thanks, Fei.
Yeah, I think maybe orchestration workstream is a good place for it. So if you're gonna have any meetings or notes, please add it to workstream document.
Sounds good.
Thank you. Any other questions about this new API? Okay, then now it's my topic. I want to give a small update on DRA workstream. Last time I showed the document what is planned for DRA. And I think on device management Slack, just today, there is a discussion how exactly like mechanics of it will look like. So one enhancement or multiple enhancements. I'm not sure the proper solution right now, but scope is still the same. The only difference is, as I said yesterday, last meeting, I'm going to propose this failure mode, like exposing device health in a pod status. So I set the cap, and I would appreciate some feedback. I really hope that we can get it into 131 so we can have some visibility into failures. And then as the next steps, we can start reacting to those failures automatically and improve user experience this way as well. Any questions? Okay, I see. So John, John, you're here. Do you have anything to add?
I'm sorry, I'm doing two things at once. I wasn't listening. Apologize.
No, I just saying that scope stays the same, like as we discussed last meeting, and you're just working on mechanics of it, like how to express, like how to do it in a single cap or multiple caps, just kind of thing.
Yeah, I mean, yes, the scope is roughly what we've discussed before. I mean, there's things on the bubble, whether they come in or out, depending on our capacity. But we're iterating. It's a challenge, but we're making progress. I don't have much more to report there.
Okay. Jackson, do you want to talk about multi-host?
Yes, I think we're preparing the next meeting. There's few topics at this moment. The first is the distributed inference on leader worker set walkthrough. I think I'm still coordinating with Abdullah on the timeline. I think probably sometimes next week, probably Tuesday or Thursday. And the second thing is more related to the like multi-host as well. So I do see a lot of like models right now deployed on different devices, but because the fraction issue or limited capacity issue, they have to leverage different chips to deploy the same model. In that case, like the routing side have a lot of like issues. For example, the request come to the slower GPUs that's actually become slower and slower, and the inference engine accumulate more like requests comparing to those better hardwares. So we're thinking like Kubernetes layer, like what's the best abstraction so for those like GPU compute power, and whether there's some pluggable mechanism we can use to do the better like request level routing. Yeah, so that's something happening on the multi-host. Yeah, we will try to tackle. Yeah. Yeah, I'll send the meeting invitation probably later today. Yeah.
In the second case, are you referring to like just like A100 and assuming that A100 is the lower end GPU and H100, like you start routing to it's not necessarily multi-host, like you're not actually distributing the model itself across multiple devices. It's that you're deploying it on heterogeneous devices, right? Like
heterogeneous. So I think the current case is heterogeneous. For one deployment, like distributed way, I think people, at least from our like experiences, we'd rather not to deploy it on like mixed machine pools if we use the TP, because the synchronization is kind of slow. Yeah. But for example, our case is we have a like a large model. We have limited 800. Now we have some L40. L40 is have like 48 GB memory. I like to leverage those GPUs. We have like 1,000 L40 GPUs. We like to leverage that more. So we do have some deployments. From the routing side, they all contribute to the model's throughput. We actually route to different like deployments. Yeah.
Isn't the choice of like where you send traffic depends on your capacity situation, right? Like,
Yes,
I'm still getting the problem where, like, why would you continue to send your traffic to the lower end GPU? I mean, you would only do that if you're having capacity challenges on, let's call it quote unquote, the more optimal hardware that you would like to use.
Yes, I think that's more related to the capacity limitations. If we do need the scale up, we don't have like 800 GPUs at this moment, so we have to use the lower end. Even it's a little bit slower.
And the question here is, how do we express that intent that use A100 if you don't have fallback to L40? Is that what you're trying to standardize on, or something else?
Yeah, I'm trying to standardize one thing. Like, if we think the L40 is slow, so how can we? So that means every pod, it has some like probably throughput numbers, right? So how can we standardize the model deployment on different chips, and we know the throughput it can provide? So that will be used to as a guidance for the routing part, make it more like fair. Yeah.
Do you plan to have a more detailed description of the use case, like in the next meeting?
Yes, I can provide more cases. Yeah.
So question, so when you're talking about kind of heterogeneous hardware, right? You are saying for the same model, for serving a model, that for serving that model specifically, you wanted to have a homogeneous pool, right? But across, say, when you're routing, you can be routing to different type of pools, right? But you are not like, say, serving a large model, you'll mix, say, your L40s or A100s. Or you are thinking about actually mixing your A40 and A100 serving a single model?
Yeah, that's probably like two different stages. So at this moment, we do use two different deployments and two different services. Like one maps to one specific like GPU chip, and from the router side, from the proxy side, because they all belong to one model. Let's say like some like GPT-4 Turbo, right? In that case, it's the heterogeneous like deployment for one model. So the proxy handling, the routing side needs to be like handled carefully to make sure there's no accumulated request, there's no like hot instance, etc. And yeah, so the second step is on Kubernetes side, we know we can only use the kind of we normally like specify like kind of the node selector to choose one like GPU for the one deployment, right? In future, what's the best abstraction? So that part we don't know. That's a kind of the open discussion. Yeah.
Okay.
Yeah, I guess that's where DRA fits in. I guess because it should eliminate the need to set like those node selectors, and you basically you're able to express the intent on the resource request, I think.
Right. I think the Kubernetes layer, if we have the capability, we also need to make sure, like as we talk, like the service level, the route is balanced, or like those issues needs to be resolved as well, right?
Yeah. I'm just trying to think, what is the feedback loop here specifically? Is it like capacity is one, right? Like, because that's your main signal. Like choosing between the two or the two flavors is always going to be based on your capacity, isn't it? Or like for the most part.
Yes, that's true. Yeah. The capacity or the throughput it can provide, that's the kind of difference between chips. Right. I think, yeah, if people have like more similar use case or have like further questions, let's just come to that doc and leave some comments. Yeah, we can use that meeting to discuss more details on this problem.
Okay, is there any more questions? If not, then we go to the next topic is from Ashok.
Yeah, I just wanted to provide an update on metric standardization work. So we have a PR in OpenTelemetry semantic conventions repo. So the goal with this PR is to standardize the name of these metrics, how we bucketize these metrics, and set a standard for those things. And then each model server can then directly use these standardized metrics and conventions, right? So if anyone has any thoughts or you are specific about how you would like these model server metrics to be called, please take a look at this PR and leave any comments so we can finalize on the terminology that we want to use. And we also have issues created on the different model servers like PLLM, TGA, etc. And Ivan has been helping drive the TGA side. So yeah, we are still in some early discussions around what some of those metrics mean and how we can add these to these model servers. If you're interested in the TGA or VLLM side, please take a look at those GitHub issues as well. Yeah. So.
Is there any questions about metrics? Okay, then. I think before we conclude the meeting, I want to remind that CFP for KubeCon is coming up. So if you were planning to submit any talk, please do it shortly. And yeah, watch out for upcoming meetings. I think this week we only have one upcoming from about LWS, but it's not scheduled yet. So yeah, anything else before we conclude? Okay then, thank you everybody. Bye-bye.